Hi viewers, welcome to SS Academy channel. Today we are going to discuss about 12th Physics Volume 1 Unit 1 Electrostatics 3 and 5 mark questions. Okay, let us discuss the question first. So before starting the question, we want to know about some basic definitions. Torque. Torque is the twisting force that tends to cause rotation. The point where the object rotates is known as the axis of rotation. So the mathematically, torque can be written as T is equal to F into R sin theta, and it has units of Newton meters. Next, the electric dipole. The electric dipole is nothing but there's two equal and opposite charges separated by a small distance constitute an electric dipole. Then next we know the electric field. The electric field at the point P at a distance R from the point charge Q is the force experienced by a unit charge. So let us see the question. Derive and for torque experienced by a dipole due to a uniform electric field. Okay, so we want to derive for a torque experienced by a dipole due to a uniform electric field. First, the considered an electric dipole of dipole moment, we know P vector, placed in a uniform electric field. Okay, so the charge plus Q will experience a force. Plus Q will experience a force is a QE vector in the direction of the field, and the charge minus Q will experience a force minus QE vector in the direction opposite to the field. Okay, since the external field is uniform, so the total force acting on the dipole is 0. Okay, so these two forces acting at different points will constitute a couple and the dipole experience a torque. So the two forces means the two equal and unlike parallel forces are not passing through the same point, isn't it? So resulting in a torque on the dipole, which tends to set the dipole in the direction of the electric field. So the magnitude of torque is tau is equal to one of the forces into perpendicular distance between the forces. So one of the force, what force? F into perpendicular distance is the 2D sin theta. Okay, so the forces is a QE. Okay, charge and electric field QE into 2D sin theta. So it is P is equal to 2QD. So can I write PE sin theta? So next, tau vector is equal to P vector into E vector. So we get the tau vector is equal to P vector into E vector. A dipole in the electric field experiences a torque which tends to align the dipole in the field direction, dissipating its potential energy in the form of heat to the surroundings. Okay, so the next, when theta is equal to 0 degree. So theta is equal to 0 degree mean it is the tau also 0. So the dipole moment of dipole parallel to electric field is a no torque. Okay, so when theta is equal to 90 degree now, tau is equal to PE. Okay, so the dipole moment perpendicular to electric field, that is torque is the maximum. So the next, theta is equal to 180 degree, that means tau is equal to 0. So dipole moment anti-parallel to electric field. So torque is a 0. Okay, hope you understand. Then next is the it is a microwave oven. It is used to cook the food in short time. When the oven is operated, the microwaves are generated, which in turn produce a non-uniform oscillating electric field. The water molecules in the food, which are the electric dipoles, are excited by an oscillating torque. Hence, few bonds in the water molecules are broken and heat energy is produced. This is used to cook food. Okay, so the microwave oven works on the principle of torque acting on an electric dipole. Hope you understand. Thank you.